86% of organizations think that within 5 years, microservice architecture will be their default architecture for new development, strategic development. And the biggest part of that, most of them saying that the reason is need for business agility. The idea is that teams can independently deliver the code that they're working on, faster time to market, faster feedback from their customers. So a lot of you said you were doing it. You probably know then that the table stakes for this are fairly high. The things you need to be doing to be effective at it are pretty high, and there's a lot of things that go on. And what I want to talk about is that one of the key parts of it, and that is sometimes an Achilles heel in what teams are delivering, is the elastic and resilient infrastructure that goes underneath this. Even if the application development teams are doing a great job on some of the other parts of this, committing to trunk daily, CI/CD of their products, how can they deploy consistently onto an infrastructure that keeps up with them and what they're doing? The rate of change into that infrastructure is the same as what's going on in their application products. Okay, so I'm going to talk about the what you need to do, why it matters, and how you might go about setting into that. The effective delivery of a distributed computing platform is what we're talking about here. So there's two key, these are like first principles, foundational architecture things that you need to keep in mind when you're developing these systems and never step away from, never back off. And the first one here is deploy these platforms using the same practices you do when you're building your applications. So test-driven development, continuous integration, continuous delivery of the infrastructure platform. And the second piece I'm going to cover is these platforms that you build, they need to be the ones solving the solution for the availability of those services, not the individual application teams as they create those services. Now, you might say that these things at this point are starting to become more and more self-evident, but I can tell you going into enterprises of all different size, Fortune 50 on down, the gap between what people think they know and what they're doing actually on the ground can get pretty huge. And these are things you can't step away from and expect the outcomes to be what you want. So the first part here, what continuous delivery of this infrastructure platform, why does that actually matter? Why is that important to never step back from? Now the process science term for this is single piece flow. Most of us heard about that, made famous with Toyota and their lean manufacturing processes. But I'm actually going to use a different example, and I like this one just because it simplifies it. This is a farming example in produce, and you can see here that from picking it, washing it, sorting it, packaging it, and putting it on the truck to go to customer all takes place as far left as possible. And it's optimized for that continuous, that whole piece, not individual silos of what needs to get done. And the quality of the product then that goes to the customer, the amount of waste, the per unit cost is dramatically different from the farming enterprises that aren't doing this. So that's what you're doing. If you're building an API, let's say, and you're engaging in continuous integration and delivery, that's what you're trying to do is take the entire process of everything that you're doing, the building it, the testing it, and testing it thoroughly in the environment that it's going to go to. You're pulling that as far left as possible and away from the customer in order to immediately validate what's there and then be able to react on the fast feedback you're getting from those customers. And I'll contrast that then with the alternative that most of us are familiar with, particularly in infrastructure, and that's batch and queue. And the idea is that for every change that's introduced, you've got system administrators, security operations, maybe service delivery teams that operate those environments for you. Each one of these teams, even if they're using some degree of automation, it's separate and the work's getting thrown from one functional silo to the next, and they're optimizing it within their own silo rather than optimizing for the entire process. If you start engaging in those things, it's very, very difficult, if not impossible, to break out of them. So if we're going to build these things in infrastructure, in software, what's the scope of the configuration that needs to take place in this automation? And the idea is it's everything. It's all of it. Everything that goes into that environment that you're deploying your code to needs to be built in software. So it's the things we think about, often in all the parts and pieces they're moving and how they get into the cloud, networking, routing, DNS storage, the compute, the services that support observability behaviors you're engaging in, all of that needs to be built into it. And also, as Kate was saying, the secure configuration of all those things, that's a part of the pipeline as well. Why is this important, so important? Well, this is what your application developers are trying to do. They want this fail rate between environments metric to look like this, meaning when they deploy and test it the first time, they expect to catch all the issues, whatever they might be, such that when it moves to the next environment, if you get a green in the first one, you're confident that it's going to go all the way to production without issues. And to succeed at that, because let's face it, most of the times that it fails are environmental or production data related type things. For that to succeed, that means that the infrastructure they're deploying onto needs to have that same curve, but happen before they deliver to it. So notice where I've drawn the lines for production for application folks. This is production in their minds in terms of when their customers see it. If you're building the infrastructure, this is where production starts for you. Because all these tests are attempting to prove that it'll run live in production. That means I need to be live in terms of my production and infrastructure environment needs to be prod-like from this point forward. So if I'm the team engaging in building this, I need to be able to test every change into my infrastructure early on, deploy it, vet it, and then it's ready to roll into production for these teams to consume it. What are some anti-patterns to notice if you're not doing this? Some of the key ones to look for is that I'm not using immutable patterns in the way I build this. In other words, are the servers long-lived and I'm trying to maintain state and keep it consistently? That's not the direction to go. Use immutable patterns. The frameworks that I deploy these things with, are they idempotent? Meaning, small change, large change, I can confidently run the configuration over and over again and always know that the results are going to come out. Testing different things in different environments rather than testing comprehensively in each environment. These are things to look for. Why did I use? I went back to a produce example for looking for these smells. I use that because in a grocery store, the produce section is one of the shortest shelf life things in the grocery store. And that's the difference between infrastructure code, let's say, and application code. Any change you want to make in your application, you have to go and do a git merge to push that forward. They're not alternative ways to change your code. But when you're building infrastructure as code, no matter how mature your product is, no matter what environment you're talking about, there's always another way to go make that change. You can log into the console in Amazon and make a change. You can log into a server and make a change. You can run a tool from your workstation and make a change. And every time you do that, you're breaking down a process. You're breaking down your code ability to address it. So this has the shortest shelf life of any of the code you'll make. And the idea is you need to keep that in mind and maintain it the way grocery stores maintain their produce. They have to keep all eyes on it all the time. And we talk about how. This is an example, actually, of a repeated pattern I've used that's very effective in Amazon. If you're the team building the infrastructure product, then you have some of the same concerns that your application development team has in the business capability that they're building. And that means independent deployability around the various APIs and the functions that they make available. We need that in the infrastructure as well, meaning that whichever area I'm trying to push change down, I'd like to be able to push that down without it disrupting everything. Certain parts of this pipeline experience change much more frequently than others. I don't want to rebuild the whole thing every time. How do I pick good domain boundaries between the capabilities that are there? In Amazon, there's a grouping of things that create permissions and rights and roles. I'll focus on roles for a minute. If you think about it, if you're familiar with using those roles to define what capabilities you have, there should be the same definition and set of roles in every single environment in your infrastructure, so that when you change a permission, you create a new role, you test that in the first one, and those get pushed all the way downstream. And that's something that changes frequently, so it needs its own pipeline. Another one down in Kubernetes, we're going to talk about that in a minute, but we've kind of ended up dividing these into two sets. There's the underlying core configuration of it, and whether you're using KOps in Amazon or you're being maintained for you in GCP, the idea is there's still a lot of configuration that you'll do in setting up those initial ones. If nothing else, you're going to be doing a lot of security changes using something like kubench to make sure that your CIS level security inside Kubernetes is where you want it to be. So there's a single pipeline that there's a version state of those things that gets pushed down through into production. Whereas Kate Core, those will be the things that you, maybe as an infrastructure team, deploy onto that cluster. Maybe that's Fluentd log aggregators, Datadog agents, very important, your service mesh that's going to control or deal with service communication. So you have a way of versioning that combination of things and pushing change down a pipeline. So the second piece I was talking about, this platform now that you're building an infrastructure and your infrastructure software pipeline, it needs to be the thing that's solving for service availability. And why is that important? The key thing to keep in mind here, the base principle, is what it is that we're building. We're building a distributed computing system. Most enterprises, most of us get started in development, and we can assume a couple of things when we're writing code, and that's consistency and availability. Meaning, maybe your first project was a JVM, and all the capabilities of the package are in that, the software was in that one module that was deployed, and you made it highly available by putting 10 of them behind a load balancer. But you could expect that customers, their user journey going through that, the communication between each of the methods and modules inside that software would be consistent, because it's all taking place in proc on the same machine. But with distributed computing, we're not doing that. In other words, we're breaking apart those capabilities, and we're making them independently deployable, and we're taking all that communication and we're pushing it out onto the network, which isn't consistent. And it's not reliable. We can't depend upon it being there. So instead of having consistency and availability, what we actually have is availability and having to manage what happens when we can't talk to each other. There is inconsistency in it. I don't know if you're familiar with Eric Brewer. This is called CAP theorem, C-A-P, the beginning, and Eric Brewer is VP of Infrastructure at Google, but there's some other folks, Lynch and Gilbert, if you haven't read some of the things they've talked about. This is an actual theorem, an actual principle you're not going to be able to overcome, and instead architect for it and take advantage of the tools that are there to solve it. By the way, that availability includes elasticity, meaning I'm available no matter what, how many services I have out there, and no matter what the load is on them. These are the key parts of that, meaning for those services that you're deploying that have inconsistent communication with one another, the discovery of those things, scheduling, orchestration of them, communication between them, telemetry, those things need to be solved by the infrastructure platform that you're deploying them to, rather than by the teams building those APIs. This is a good example, I think, in software of mechanical sympathy. I don't know if you're familiar with that term. But the idea is I don't necessarily have to know every bit of the math behind why distributed computing has this behavior. I don't even necessarily have to be the one to write the solution to understand it well enough to make good use of it. But I do know that I need it. There's an outcome I'm trying to get to, and I need to become very proficient at using the tools that are there to get the results that I want. So how? Here's an example of how. I've kind of put the IIS provider merged up into the platform that you're building. The lines are getting kind of blurred between those two because now there's a lot of companies that are providing this service availability for you. GCP, for example, and now Amazon with EKS. And I keep referring back to Kubernetes. It's been my experience, and a lot of other people's, that this is one of the most effective tools for doing this right now. In other words, the opportunities that they've had to test this, the folks that they have working on it, the results are really good. There are alternatives, Pivotal, Cloud Foundry, Docker Swarm. There's other ways of going about it. But if you're building a distributed system, use that tool, deploy it in the pipelines that I talked about, and become, if you're the customer on this platform, become very proficient at understanding what it is and not trying to solve for the solutions it's giving you independently. So what might be some ANI patterns or code smells related to that? Basically, pick any one of those things that the service availability is doing for you. Don't build a separate solution for that and deploy it onto this platform alongside of it. Service discovery is an area where sometimes people do that. Another one I've seen recently with Scala developers, and if you're familiar with this, but you can use Akka and you can deploy clusters, clustered Akka streams, and in effect be creating a parallel service availability system on top of Kubernetes and a way of maintaining communication, but you're stepping outside of the pattern that's there, and it's not as resilient and available in terms of the scalability and the way it responds to uncertainty as to where that service might be running and where in your platform that it's at. So avoid those things in deploying on this. So just to summarize then, the two key principles, don't ever break away from these while you're building these things, is deploy this platform using the same things you use your software. It's in pipelines and it's test-driven development, continuous integration, continuous deployment of the infrastructure. And second, for your customers building solutions to run on this, let the platform solve for the service availability issues. That's it. Thank you.